In this demonstration, we'll take a look at the TCP header using a packet sniffer like Network Monitor. Now in this example, I used Network Monitor, but you could use any packet sniffer such as Wireshark if you wanted to as well. So I launched Network Monitor, and I'm going to open up a packet capture. I'm going to use the one that I used in my previous demonstration, which is the HTTP packet. So in this example, we want to take a look at the TCP header specifically. So what I'm going to do is I'm going to pick not just a TCP packet, but I'm going to pick an application layer protocol such as HTTP, which uses TCP as its layer 4 protocol. So I do select HTTP, and you can see here in the frame details that I have the layer 2 header, which is the Ethernet header. I've got the layer 3 header, which is the IP version 4 header. And then I have the TCP header, which is our layer 4 header of the OSI model. Now, when I expand out the TCP header, a number of fields here that are useful. First one is we have the source and destination port. The source and destination port are used to identify the application that the packet is coming from and the application that it's headed to. So here I can see that it's destined for port 80, which is typically a web server. And the source port is a number over 1024, so it's probably a web client like a web browser. Within the header, we can also see the sequence number and the acknowledgement number for this packet itself. So this is sequence number 514, and we're acknowledging a previous packet that ends in 293. Now, below that, we do have the TCP flags. So I can see here the flags line. You can see the A and the P. So that's the ACK flag or the ACK bit being set, and the push flag as well. Now if you want to see kind of the details of the different flags, you can expand those out, and we can see here a number of different TCP flags. So a few that I want to identify here is we do have the urgent flag and the push flag. So as we mentioned earlier, notice that the push flag is set here. So we're trying to force the data on the application. But notice that we also have some really key flags here, like the ACK flag. Or the ACK bit is set, so this packet is acknowledging a previous packet. Notice that we also have the SYN flag, and the SYN flag is not set in this example, so this is not a packet that's part of the three-way handshake. We have the FIN flag, which is used to end the conversation, and also the reset flag, which is also used to end the conversation, but that's more of an impolite way of ending the conversation. It's similar to hanging up the phone versus the FIN flag is a polite way. So it's like saying goodbye to somebody. You wait for them to say goodbye and we end the conversation. So each of these flags are identifying very special packets in a TCP conversation, whether it's a packet like a SYN flag or a SYN message that's used to set up the conversation, or whether it's something like a FIN or a reset that's used to end the conversation. We also have other fields here in the TCP header, like the checksum, which is basically a way to validate or ensure the integrity of the header itself. So in this demonstration, we took a look at some of the key fields within the TCP header.